Hello, hello, all you beautiful people, techie and non-techie alike. I want to introduce you all to Steve, the magical pharmacist for all the members of the prominent Shadow Wizard Money Gang. Steve had an incredible journey to get here. As we can see, he started off as a simple, lowly raccoon, just trying to figure it out, making his way in the world, as one does. And today, we'll be learning about his journey and process to become the most well-known magic pharmacist in the realm of wizardry. No, but seriously, today we'll be covering the basics of Stable Diffusion AI and ComfyUI, so everyone can have their own version of Steve, or whatever else your heart desires. And don't worry, there will be no coding or high level of understanding necessary, because today we'll be using Compute Grid and their one-button click to save time and headspace. So that way we can focus understanding our nodes, our edges, and everything in between. So as I mentioned earlier, we'll be using a site called Compute Grid. Compute Grid is just a GPU marketplace. It lets users rent out other people's available and unused GPU power. I use a GPU marketplace because right now I have a very basic setup and laptop. I do not have that good at graphics processing, so I like to just rent out someone else's machine and have them do all the heavy work for me when I need it, and that way I don't have to pay tons of money to upgrade my setup just yet. But I use Compute Grid specifically because they already have Stable Diffusion XL and ComfyUI pre-installed to all their instances. So when I log in, all I have to do is go to All Instances, and then just find one I want to use. From here, just click Start Instance. And then it'll just take a few seconds or a few minutes just to finish the setup process. Alright, perfect. So now that our setup process is complete, we get taken to the instance detail. And right below the example machine learning workflows, we have a tab for OLlama and Llama 3, which are a language learning model, kind of like ChatGPT, but we're here for SDXL. From here, all we have to do is click Launch DXL, and it goes ahead and it runs all of these commands for you here and installs Stable Diffusion and ComfyUI. And just like that, in a few seconds, I'm ready to begin. Alright, so let's start with the basic text-to-image prompt, text-to-image workflow, kind of like the default workflow is here. Let's go ahead and click Queue Prompt, and we can see it run through the nodes, and this little spaghetti right here is called Edges. From here, we can see it go and get our default image. Woo! Looks like that! We have a text image. But obviously, there's a lot more to it than just that, so let's do what Steve would do and break it down. To do that, let's go ahead and clear everything. Alright, so first thing we're going to need is an empty latent image node. To add nodes, we either can right-click, add node, and find what we're looking for that way, or my preferred way is to double-click and get to the search. So let's go ahead and look for empty latent, and there it is, empty latent image. So latent just means existing in hidden or dormant form, so we can think of this kind of like a blank canvas. Essentially, everything has to come from something. So we take an already existing hidden image and then we diffuse it over time to get the image that we want. Since we're using Stable Diffusion XL, we can change these pixel width and heights from 512 to 1024. We also can control our batch size here, or how many images we can make per run. I'm going to go ahead and keep this at 1 for now. Next, from here, we're going to need a load checkpoint node. It's one of the first ones we see on the search screen. So this node just loads our model and checkpoints. So Stable Diffusion checkpoints are just pre-trained models that have learned from a variety of image sources, so they're able to create new ones based on that learned knowledge. Today, we're just using the SDXL base model, but in reality, there are hundreds of model options. If you'd like to explore additional models, you can go to websites like Civet AI. All you have to do is make sure you're filtering for checkpoint and SDXL 1.0. From here, all you have to do is find a model you want to use and click download. If you're like me and using Compute Grid, you would just instead copy the model download link, pull up your terminal, and from here you'd SSH in using your commands and password. You'd go ahead and you'd go to find your ComfyUI folder, and then just do wget URL to model. And don't worry, I know that was pretty fast, so I'll include the links and instructions in the description below. But let's go back to our load checkpoint. So just to recap, this load checkpoint just loads for us our checkpoint model. A Stable Diffusion model is going to have three main parts. The model, of course, which helps predict noise in latent space. This one right here is VAE, or Variational Autoencoder. This converts the image between the pixel and the latent spaces. And then right in between is Clip. Clip is OpenAI's language model, and it pre-processes the positive and negative prompts, which leads me to our next two nodes, the text part of text-to-image. Since we already know it's going to be connected to this clip output here, we can just drag this edge out and see what options we have. Clip text encode is what we're going to grab. As you can see, it already has prompt in the title, so we know we grabbed what we needed. Now, my observant friends may recall that I said it pre-processes both negative and positive prompts. So we need one more clip text encode here. Now, you may be wondering, how do you know which one is positive or negative? Well, I can explain that, but first, let's go ahead and grab a K-sampler. This K-sampler is actually the heart of image generation Stable Diffusion. It's so important, that's why it's one of the first things you see when you're on the node search. Alright, so as you can see, on the left-hand side are our inputs. We have two orange ones, one for positive and one for negative. We also have an input for model and input for latent image. I'm sure you already noticed it, but just in case, whenever you pull on one of the edges, it will only light up on the input it can connect to, so purple model to model. So that way, if you ever get confused, the colors help a lot. Additionally, if you also want to keep yourself being confused in the future between the negative and positive prompts, you can always just right-click and change title and colors. I'm going to go ahead and make our positive prompt green, and then make our negative prompt red. Alright, now let's get back to this K-sampler. The sampler uses these parameters here to denoise a random or latent image into one that matches our prompt. The seed is just a unique value that controls the initial noise of the latent image and hence the composition of the final one. Control after generation does what it sounds it does. It controls how the seed should change after each run. It can either be unchanged, increased by 1, decreased by 1, or random. Below that are steps. Steps just refer to the number of sampling steps. Essentially, how many loops to go through to denoise the image. CFG we can think of as camera aperture or detail level. But warning, higher is not better. If you make it too high, you can burn out your image, which just makes it look all white or burnt looking, kind of like how you would burn out a real image on a camera. Below that is sampler name, where we can set our sampling algorithm, scheduler, which controls how the noise level should change each step, and then lastly denoise, which is how much control AI has over the erasure of the initial noise, 1 meaning all. Now you may think our image is done and we should be able to click our handy dandy Q prompt, and bada bing bada boom. But if you look at the output of the K-sampler, you'll see it actually outputs a latent image. So it's not quite the image we want just yet, but it's close. It is a compressed, not yet human-readable version of the image. So we need to decode it using the VAE decode. If you recall, VAE converts between latent spaces and pixels. Basically, it works to decode an image, something that we can see, or encode an image, something that AI can use. Our base model already has a VAE output, so we'll connect them like so. But some models may not actually come with a VAE, so if that's the case, you would need a load VAE node. A load VAE node like so. But ours already has one, so let's go ahead and remove this. Alright, let's go ahead and connect our decode to our latent image. And so now we have our blank canvas, we have a model loaded, we have a positive and negative prompt, we have the heart of this operation, the K-sampler, and a decoder to make sense of it all. So now we just need the image part of our text image. Let's go ahead and drag our output to this empty space and see what options we have. We have one for save image that can save it directly to our folder, or preview image. I always say do preview image first so you can make sure that the parameters are working the way you want it to and your image is the way you want. And that, my friends, is the complete text to image workflow. Minus the text part and the image part, for right now at least. So let's go ahead and add our text and see if we can recreate Steve. In my positive prompt, I'm going to put what I want to see, which is a magic raccoon, I spelled raccoon wrong, with a wizard hat and drugs. PSA kids, don't do drugs. Steve is a professional pharmaceutical representative. Alright, and then so for my negative prompt, I'll add what I don't want to see. So, watermarks and words. It works better when you spell properly. Fun fact. Alright, so from here we can just click our lovely Q prompt button and let's see what we get. Okay, so Steve looks a little different here. Not quite what I was envisioning the great magic pharmacist of the Shadow Wizard Money Gang would look like. So let's see if we can fix him with image to image. To do that, first we'll need to grab a load image node. And then we can select what base image we want to use. There it is. This right here is Steve's cousin Daryl. He's going to help us out today. But hey, Daryl looks pretty human readable, so that means we'll need a VAE encoder so it's AI readable. Oop. And as you can see, our VAE encode already has an input for pixels that matches our image output here, so we can connect them like so. We also connect the VAE to our load checkpoint VAE here. Now, you may notice that our VAE encode has an output for latent. This is because this right here is going to take the place of our random empty latent image instead. So we can go ahead and connect it like so and replace that. Alright, now from the top, let's see what we get. As you can see, it went ahead and took this image here instead of the empty latent image to start everything up. Ooh, alright, so that's pretty close. Let's go ahead and adjust some steps and some things and see if we can get even closer. I'm gonna go ahead and move this to fixed, that way it doesn't continually randomize the seed, because I want to keep this seed the way it is. Let's go ahead and adjust our steps a little bit. I'm going to lower the CFG and just see what we get that way. Oh, would you look at that? I'm just going to denoise it a little bit. That way, it looks a little bit closer and he looks a little more related to his cousin Daryl over here. Alright, it looks like it adjusted the quality for us. And let me go ahead and add an extra step and just see what we get. All right, folks, there is Steve. Just like that, you have been empowered with the necessary knowledge to create your own Steve, or whatever else you like. Thank you for joining me, Daryl, and Steve today. We took you on a tour of ComfyUI and how to make a text-to-image and image-to-image workflow utilizing Compute Grid's easy one-click system. Thank you, and we hope you guys hear from us again soon.